Hi, I'm Mr. Kangas, and today we're going to be talking about Chapter 10, Section 8, Area of Composite Figures. So composite figures are basically just shapes that are made out of a bunch of shapes. So for example, a really basic composite figure would be one of these shapes we've drawn as kids, a house. This is made out of a square and a triangle. So area of composite figures really is just taking all this knowledge of area formulas that you've learned in the last two sections and combining it all into one activity. You now have this figure in front of you that's actually made of two different shapes. And so if you want to find the area of this figure that isn't a typical shape, you're going to have to split it into pieces. So you're going to have to take a look at this, and what really helps when you're looking at these composite figures is to do what I just did. I just drew a dotted line that splits it into two recognizable shapes. I can now see the square and I can see the triangle. And typically what they will do in these problems is they'll give you little pieces of information. So for example, they might put like a 4 here, and they would put like a 2 here, and they might put a little line here going like this, and might make that a 6. And they say find the area of this figure. Well, you know the area of the square is going to be 2 times 4, base times height. You know that squares opposite sides are equal, so you know the base of your triangle is equal to this, which is 4. And this represents the height of your triangle. So now you can find the area of the triangle. You just do 1/2 times 4 times 6, 1/2 times the base times the height, base and height. So if you actually do the math out, 2 times 4, you have an area of 8 inches squared or feet squared or whatever it may be. Up here, 1/2 times 4 is 2. 2 times 6 is 12. And so you actually have an area in the triangle of 12 inches squared or feet squared or miles squared, whatever it is, whatever unit of measurement you're using. So just in case you didn't see that last part, I did 1/2 times the base of 4 times the 6. So I did 1/2 times 4. Multiplying by 1/2 actually cuts the other number in half. So half of 4 is 2. Drop down to 6. 2 times 6 is 12, and that's where I got that 12 from. And the 4 just represents the length of the base. So I'm going to erase that so we don't think it's part of the area. So now that we've solved the area of the square and the area of the rectangle, I should say, because I made this 4 and this 2. The area of the rectangle and the area of the triangle, we now would combine the two for a total of, we'll say these are inches. So we now have a total area of 20 inches squared for my figure. Now in some of the pieces you're going to be looking at, you're going to have much more complicated figures that may need to be split into 3, 4, or 5 pieces. And so you're going to want to be good about your lines, and you're going to want to pay attention to the information they give you. What lengths, widths, and height have they given you? What dimensions have they given you that you can work with? So I'm not going to do another example because I think this kind of gets the point across. The only other thing you're going to see are just bigger shapes with more shapes inside them. You're going to see primarily parallelograms, rectangles and squares, and triangles, and some trapezoids. You won't really see circles too much. Where you will see the circles more so is you might, for example, get a circle, and that circle is shaded in. And they may have a hollowed out space inside the circle that looks like a triangle. And the question may be, how do I find the area of the shaded in region? Okay? And they will tell you that the diameter of the circle is 6. They'll tell you that they'll give you the dimensions to the triangle. Let's say the dimensions triangle, it's got a 4 and a 10 for height. Okay? and they'll want you to find the area of the shaded region. So all you do is you find the area of the actual circle. Okay, so you're going to find the area of the actual circle, the whole circle, including the shaded area and the blotted out area combined. Okay, so if you find the area, it gets you the whole thing. Then you would find the area of the triangle, the blotted out area, the white area, and you would subtract that from the whole area because this chunk of the area is missing. So you find the whole area, find the area of the missing piece, and subtract the missing piece from the whole. And what's left is the area of the shaded region. So that's kind of how you tackle those problems. A lot of those problems that have shaded in regions you need to find the area of will actually have multiple shapes inside them, or multiple chunks missing in that you're going to have to account for. So if you have any questions on any of that when you get to the worksheet, let me know. Raise your hand. If there's, maybe you feel like there should be more examples or more complicated examples, I can totally add that in at some point. Just my instinct tells me that having more complicated examples won't accomplish much. You'll probably just get bored. The concept is there. You understand the concept. It's just a matter of taking the time to get the area of all the individual pieces. It's not a difficult concept. But if you are struggling with it, please let me know.